Okay, chicos, here goes. 3 theorems involving proportions. First one's called side splitter theorem, and it is fairly self-explanatory. Take a triangle, then inside the triangle, draw another segment between 2 sides that is parallel to the third side, and the segment will divide up those 2 sides proportionally. What does that mean? In this case, for example, if BD is parallel to AE, then AB is to BC as DE is to CD. All right, again, a segment splits 2 sides of a triangle and breaks it up into proportional parts. On to theorem 2. 3 lines, 3 parallel lines, and 2 transversals. So, draw 3 parallel lines, and then 2 transversals, which are, I'm going to draw them not parallel. All right, I'm going to use small letters to denote lengths. And we better get our parallel symbols here. All right, so if we have 3 parallel lines, then A is to B as C is to D. This is almost like the last problem, except that we don't have a triangle here. You can kind of visualize it as a trapezoid, if you would. So of the 2, this is kind of the more generic one. It works for anything, and then the triangle, the side splitter one is specific towards the triangle. Okay? Hope that helps you solve some problems. Our last theorem, trickiest one of the bunch, is called the angle bisector theorem. We start with a triangle, any ordinary. I'm going to try to make mine scalene. And I'm going to bisect this angle. It doesn't look too good. Let's do a little better job. Nah, that doesn't look good either. Better. There we go. So, these 2 angles are bisected. We continue that down to this third side. And what we find out is that, again, I'm going to call A, B, B, and then C, and then I'm going to call this segment D and this segment E. Okay? So, based on the angle bisector theorem, we have D is to E as A is to B. This one is kind of unintuitive, and it's a tricky one to prove. Book kind of walks you through that. I'm not going to bore you with those details right now. Those are the 3 theorems. And now for a sample problem. Okay. The easier side will be side X. So using my side splitter theorem, we've drawn an interior piece which is parallel to the third side. I can now say 2 is to 4 as X is to 7. In this we can solve quite quickly and say this is 7/2. I think it reduces down to that. Hopefully my mental math is okay. Now to get Y, a little bit trickier. Notice Y is a side of a triangle, and that triangle is similar. The big triangle is similar to the smaller triangle. So we're just going to set up a proportion like we did in the last few sections. So for example, 4 is to 6 as 6 is to y. Okay? Again, 4 is to 6 as 6 is to y. Does that make sense? So I think here we end up with y being equal to 9. Hope that helps, makes sense. Good luck in your work, and try to do it quietly